Hello viewer, welcome back. I'm Dennis Ongweso. We are going to continue with our previous topic, but under a different subtopic. But before we proceed, we can remind ourselves what we learned last time. So last time we looked at the DC circuits, and we managed to cover DC series circuits. And under this circuits series, we discussed about Ohm's law, and we said that Ohm's law states that the voltage in a DC circuit, on an electrical circuit, is directly proportional to the applied voltage in the circuit and inversely proportional to the resistance in which is being subjected to. We discussed that current is given by V over I, R, and we managed to derive an expression of how to find resistors in series, the total resistance in series. We came up with this formula. So this is what we managed to cover last time. But for today, we are going to deal with another subtopic, but under these circuits, which you call DC parallel circuit. DC parallel circuit. In this parallel circuit, also the aspect of Ohm's law applies. But in this, the arrangement is different. You can have an arrangement like this. You can have an arrangement like this. We have three resistors. They are being connected in parallel. Here we have the source of EMF. We have the current. But now this, in conjunction with Ohm's law, we normally apply another law which we call Kirchhoff's current law. So apart from the Ohm's law, we use Kirchhoff's current law, and this one states that the sum of the current entering into a junction is equal to the current leaving the junction. For example, I is coming towards this junction. After reaching the junction, the current I will split into three. For example, we can have I1, I2, I3. So from the Kirchhoff's is that the current from the source, after reaching the junction, it will split to I1 plus I2 plus I3. That implies that the current in the three loops or branches is not the same. And at the same time, from this network, it is said that the voltage is common at all points of the circuit. That means the voltage across R3, R2, and R1 is the same. Now, using the Ohm's law, which states that V I equals to V over R, this is the total current in circuit, and this is the total resistance in the circuit. So when we analyze for I1 will be given by V, because V is common in the circuit, V over R1. And then I2 will be given by V over R2. I3 will be given by V over R3. So if you take these three currents, I1, I2, and I3, plus this I, you substitute in this equation, we come up with, so this I is V over RT, which is equals to I1. I1 is this, plus I2, this one, plus I3, this one. If we can factor out V, because V is common on the right hand side, therefore we have V into 1 over R1 plus 1 over R2 plus 1 over R3 equals to V over RT. At the same time, if you can divide by V, all sides, this will cancel with this. Yes. Therefore, 1 over RT total will be given by 1 over R1 plus 1 over R2 plus 1 over R3. So this is an expression for getting total resistance in parallel or in a parallel circuit. But if you have more than 3 resistors, so this formula, we can modify it to this so that it can enhance your workings when you have more than 3 resistors. So if you have a number of resistors which are more than 3, 10, 20, you use this formula. But the final result you get, you have to reciprocate so that you can have the real value. But the fact is that the answer you get is smaller than any value here. So if R1 is 5 ohms, for example, if this is 5 ohms, this is 10, and this is 20, the total resistance you get when using this formula must be less than the lowest resistance in the circuit. So the answer you get must be less than 5. That is under this. But in some circumstances, you can have a special case of 2 resistors which might change the formula to a different one. But even if you use whichever the case, the formula will be the same. Let us see this special case. Suppose we are having 2 resistors in parallel like this. Suppose you are having 2 resistors in parallel like this. And we have said that V is common everywhere in the circuit, and I, as it enters the junction, is equal to the total currents leaving the junction. That shows that I equals to I1 plus I2. I1 plus I2. This common current from the circuit is given by V over R total. I1 is given by V over R1. I2 is given by V over R2. So if you can substitute these 3 I's in this equation, we shall have V over R total equals to V over R1 plus V over R2. If you do the same by factoring out the V, because V is common on the right hand side, so we have this. Equals to V over RT. So if you can divide by V both sides, E and E, so we have 1 over RT equals to 1 over R1 plus 1 over R2. But if you take the LCM of this, so it will be 1 over RT. LCM will be this times this, R1, R2. So this will go here R2 times, and this R1 times. If you can reciprocate the 2 sides, the left hand side and the right hand side, If you can reciprocate, then RT will be equal to R1, R2 over R1 plus R2. This is how you get total resistance in a parallel circuit when you have two resistors in parallel. But they are the same. If you use this, still you arrive at the same answer. For example, if we have three resistors, in parallel, and their values are being given. Maybe this is 5 ohm, this is 10 ohm, and this is 20 ohm. And now you are being asked to calculate some problems. For example, you can be asked to find one total resistance in the circuit. Total resistance in the circuit. Number 2, the current I from the source. Number 3, the currents I1, I2, and I3. If you are being asked such a kind of questions, using this circuit, therefore you can apply the formulas we have derived, and to start with Roman 1, total resistance is given by this. So it will be 1 over 5 plus 1 over 10 plus 1 over 15. If you can calculate that, you will get we will get 11 over 30. That implies that 1 over RT is 11 over 30. But if you can reciprocate this so that RT is on the top side, therefore 30 will be up and 11 will be down, so it will be this way. So the answer here is 2.727 ohms. As you can see, the total resistance in a circuit is less than any of the resistors in the circuit. And that's why in most connection in electrical engineering, it is being done in parallel. Like now connecting the bulbs or the equipment or electrical engineering, you use parallel connection because when you connect in parallel, you try to reduce the resistance of the circuit. Number 2, the current I from the source. From Ohm's law, current is given by V over R. But now R we are having is R total according to our circuit. So it will be V, if V was given to be 30 volts, so it will be 30 divided by 2.723. So if we take that, divided by 2.727, we have 11 amperes. So this 11 amperes is the current which is entering the junction. And now after reaching the junction, it will split into currents I1, I2, and I3. For you to get I1, that's number 3. For you to get I1, you have to use V over R1. V is 30, R1 is 5. So this is 6 amperes. R2 is V over R2. That is 330 over 10 is 3 amperes. And R3 is VR over R3, which is 30 divided by 20. So this is 1.5. 1.5. So these are the currents. As you can see, as the resistor is greater, the current which is passing there is so minimal as compared to the resistor with a high value of current. So I think you have seen how you can apply the formula we have derived. You have seen how to relate the Kirchhoff's law and the Ohm's law. So in a summary, in a view of what we have learned today, you have learned about parallel circuit and how you can relate Ohm's law and Kirchhoff's current laws. So you have stated that Kirchhoff states that the current entering the junction is the sum total of the currents leaving the junction. At the same time, we have seen that the voltage in the circuit is the same at all points, but the current is not the same. So if the current branches to different circuits, then the values differ. We have come to the end of the lesson. I've been your teacher, Dennis Ongweso. Keep tuned to Elimu TV.